All right. So perpendicular. Perpendicular lines are two lines that intersect at a 90-degree angle, otherwise known as a right angle. That symbol for line L and M says L and that upside down capital T. That is the symbol we use for perpendicular. So,
Can I get keys?
Yeah.
I'm gonna just unlock this. Probably today's the day.
Yeah.
I say Wednesday.
All right. So yeah, upside down capital T symbol. Now, a line segment array that's perpendicular to a segment at its midpoint is called a perpendicular bisector. So here, line L bisects segment AB and is perpendicular to it. Parallel lines, two coplanar lines that never intersect. Now, it has to be coplanar because this is not mentioned in our notes, but in other geometry books I've seen this. If you have non-coplanar lines, they're called skew. Non-coplanar lines, if they're not on the same plane, will they ever intersect? No, they would never intersect. They're not on the same plane. So parallel lines specifically have to be on the same plane to be parallel. That's not going to be much of an issue for us. I'm just kind of being a bit about this. So our symbol for parallel is a parallel. Usually you want to make that a little taller than what you're writing. Okay. Usually. Yep. Angle. An angle is formed by two rays sharing an endpoint. Now we name an angle three different ways. So one way is to, let's say, we name an angle three different ways. One way is to use the three letters that make up the angle. So here we have A, B, C. Okay, we could also name it CBA. But the important part is the vertex, which we're going to talk about later, must be the middle letter. That is what identifies the location of the angle. Because I can have multiple angles that share those letters. In fact, if I had a triangle, ABC, and I said angle ABC, you need to know which specific angle I'm talking about, even though all angles in that triangle share those three letters. So the reason we have the vertex be the middle point is for you to be able to locate where the specific angle is. And a little note. The letter or the vertex must be in the middle. I'll talk about vertex. Vertex is where the two rays share that endpoint, the common endpoint of the two rays, or common endpoint. Now, the other way we can name angles, for example, looking at this triangle, how many angles are at the vertex B? Only one. How many angles are at the vertex A? One. How many at vertex C? Only one. If there's only one angle there, you could just use the vertex as the name of the angle. So angle A, you could say, well, that's there, and will be an angle C. You can identify it. The issue comes up, for example, let's see here, if I had something along the lines of this. QRST. How many angles are at the vertex R? Now, there's two. If there's multiple angles at the vertex, you have to use the three letters. Okay, that tells you which side of that vertex we're looking at. So if I say angle QRT, you need to know that's this angle here. And SRT is the other. So it is important that you know how to name your angles so you can inform me what you're talking about. Okay. Now, in some cases, some nice cases, there are numbers inside the vertex of the angle. And you can use those numbers as well. Okay, so that's why this angle is named ABC, which is correct. Angle B, because there's only one vertex, or only one angle there. And also angle 1. So there's several ways you can name an angle. It's real nice when they put numbers there. It makes it pretty easy, pretty obvious what your angle is talking about. But in most cases, you're either going to use just the vertex letter or all 3 letters. So we already talked about vertex. Vertex is the common endpoint of an angle. Right angle, angle with degree of 90. This little box that you see right here, so this right here, that is the symbol that we have inside a diagram that says it's a right angle. So if you ever see that in a diagram, you know that's a right angle. Automatically given as a right angle. Acute angle, angle with a degree less than 90. Okay. Here. Obtuse angle, angle degree greater than 90. And you can have something called a straight angle with an angle with a degree measure equal 180. So once we have this written down, we're going to go to the next page and finish off our definitions. We actually have quite a lot to do today, so we may not even finish. I hope we do. I may stop at some point through here on the definitions, just go to notes, because some of them may look related for fun. All right. Just like congruent segments, congruent angles are angles that have the same measure are congruent. A at 40 degrees, B 43 degrees, and we know the measure of angle A equals to the measure of angle B. Angle A is congruent to angle B, and as I'm writing this, I realize I failed to kind of notice it's the important thing. The symbol for angle is kind of like an acute angle. Okay, so when you say angle A, you just use this little acute angle symbol. All right. Now, just like how segments have a certain symbol they use for segments versus the measure of a segment lacks that symbol, the measure of an angle starts with an M, lowercase m. So the measure, so this right here, M angle A is the measure of angle A. Where just angle A, angle A. So, important to denote how to write these symbols and to understand what these symbols are. So when you're telling me the measure, all right, if they ask, well, what is the measure of something, make sure you use the correct symbols. Have to put the M there, otherwise you're telling me something that's technically correct. We're almost, best way to phrase it, like we're learning math grammar. Okay. There's certain ways, certain mistakes you make in grammar that are, and that have to be corrected. So, you'll make that mistake, forget to put the M there, I'll put the M there when you don't need to. Or just forget the angle symbol in general. We'll fix it. Okay, because it'll cost you points. You'll learn eventually. Best to learn now, but mistakes sometimes with the best teacher. All right, adjacent angles. 2 angles that share a common side and vertex. So, share a common side and vertex. All right. So here we're gonna have angle here. So all right. So here angle ABD is adjacent to angle CBD. And it's not that you are going to use this so much in like playing something, but some of our terms, some of the things we're going to learn in this class, are going to use that phrase, adjacent angles, in their own definition. So you need to know what that means, be able to visually identify it. The angle addition postulate is what we're going to talk about today, which is if angle ABD and angle CBD, these two adjacent angles, okay, are adjacent, then the measure of angle ABD plus the measure of angle CBD equals the measure of angle ABC. So we can use that same diagram that's above us. Right, angle bisector. A line or ray that divides an angle into two equal parts. Okay. Here. Now this is going to be important. We have A, B, C. Here we go. All right. Here, the measure of angle ABD is equal to the measure of angle CB. And you can say that angle ABD is congruent to angle CBD. Now, how we denote congruence, like the segments, congruence are those little tick marks. Okay. For congruent angles, we have these symbols. Okay, it's almost like little arcs inside there. So that's how we denote congruence inside a diagram. Now, you may have multiple sets of congruent angles. So what you'll see is one set of congruent angles will have one set of those marks. Another set of congruent angles will have two sets. So if this was the second set, you would see two of these marking these sets. Vertical angles. This is going to be something that is going to come up a lot throughout this course. Okay, it's such a basic term, but vertical angles occurs in a lot of different places. So, two angles. Directly across from each other. On intersecting lines. All right. Now, one rule that's going to come up, and we may not talk about today, maybe on Tuesday when we have class again. All vertical angles are congruent. All vertical angles are automatically congruent. So anytime you see two vertical angles, you can say, hey, these two angles are congruent because they're vertical. So we have two lines that intersect. L and M. 1, 2, 3, 4. So angle 1 is congruent to angle 3. They're vertical. And angle 2 is congruent to angle 4. Basically, anytime two lines intersect, they create vertical angles. Complementary angles. Two angles whose sum rephrase that. So two angles whose measure has a sum of 90 degrees. So two angles that add up to 90 degrees would be complementary. They do not have to be adjacent. So they can be. An example of an adjacent angle. First of all, we have a right angle. Okay. We have a right angle, and there's adjacent angles within that right angle. Okay. Angle 1 and 2 here. They're automatically complementary. We know we have a right angle. There's adjacent angles in there. Those two angles are complementary. Right? Or we could just have two separate angles. Okay. We know this angle is 25, and that's not 25, by the way, still. And this angle is, what, 65? Use three symbols. So call that angle A and angle B. So both angles 1 and 2 are complementary, and angle A and B are complementary. As long as they add up to 90, they're considered complementary. Now, the idea here, you're going to be told these angles are complementary, so you will be able to set up the equation setting the sum of those angles to be 90. Supplementary angles are very similar to complementary angles. It's just two angles whose sum is whose? That should be an E, shouldn't it? Interesting. Not who is. Yeah. Me teach math breathe. So, two angles whose sum or whose measure has a sum of 180 degrees. So, 20, 60. Don't forget to use the degree symbol when you're talking about degrees. Again, it's like putting a period at the end of your sentence. It's just grammar. All right. So two angles whose sum is measured 180. They're called supplementary. Now, the last one. Linear pair is adjacent. I don't know what I'm doing. Adjacent angles that are supplementary. So there's a specific word for adjacent angles that add up to 180. Okay. Reason why they have, because combined they form a straight angle. All right, that is it for the definition. On to the notes. A lot of notes there. Let's move quick through those notes. You have 30. You get 30. Oh. All right, so we are today after segments, after picking the points, only here angles. We do know a lot of these words already. So, angle formed by two. An angle is formed by two rays that have a common endpoint. Common endpoint is called the vertex. The rays themselves are called the sides of the angle. Okay. When naming an angle using three letters, the middle letter must always represent the vertex. Using a single letter, if there's only one angle located first, we talked about this. Okay. And when referring to the measurement angle, we use the lowercase m up top. Now, types of angles, we talked about these. We have acute, obtuse, right, and straight. So, for letter A here, step one, name the vertex of the angle, that is K. Name the sides of the angle. Now, sides are rays, so you do have to note them as rays. So K, J, starting with the vertex, and KL. Make sure you write these rays. Give three ways to name the angle. There's no number there, so. Oh, wait, there are, yeah, without a number, there are three ways, because again, you can call it angle JKL, and you can also go the other way, angle LKJ. As long as K is the vertex, it must be in the middle. And then there's just angle K. Classify this angle, it is obtuse. Step 2, name the vertex, S, name the sides, SR, and ST. Three ways to name it. pretty much the same thing. RST, angle TSR, and angle S. And this one is right. Just keep moving and deleting things on the right. All right. Talk about congruent angles. If the measure of angle A is equal to the measure of angle B, all right, then the angles are congruent, which means angle A is congruent to angle B. All right, next up. In this case, we have an array. So a array that divides, it could be a line as well, but it's either a line or array. In this case, it's an array. That divides an angle into two, I'm just going to put congruent parts is an angle bisector. And the diagram to the right, the ray is BD. An angle bisector, therefore, angle ABD is congruent to angle CBD. That's later. Two lines that intersect at a right angle. The symbol for perpendicular is an upside down capital T, and the diagram to the right, line L is perpendicular to M. Line segment array that bisects. Oh, sorry. I think it means perpendicular. That's what they want. Perpendicular to a segment at its midpoint. The diagram to the right, LM, line LM, is perpendicular bisector to the segment PQ. All right, so write another name for angle CBF. You can do this since, again, you can't just use B because there's what, 1, 2, 3, 4, 5, 6, 7, 8. There's like 12 different angles there. Okay. That's one thing you would need to be able to know, that there's not just 4 angles there or 5 angles there. There's a lot of different angles. You can form an angle here, an angle here, an angle here, here. So that's just 4 angles just sharing side AB. Okay. So many angles there. You can't just use B in this case. So all you do is reverse letters. FBC. Name the sides of EB. Well, they give us the vertex, and the rays would be BE and BD, because the name gives us the vertex, and the rays had to start at the vertex. Classify the angle ABC. Now, since this line forms a straight angle, and we know that BBC is a right angle, what do we know about ABD as well? Also, we write it. Stop. All right, give an example of an obtuse angle. You can say CBE. All right, so we could say this angle here, CBE, but you could also say angle EBB, angle ABF. Okay, those would also work for obtuse. Right? You can combine multiple angles to make a obtuse angle. It doesn't have to be a single angle. Name two congruent angles where they give us little marks here for congruent angles. So this one and this one, so we know they're congruent. But since we know that angle ABD and CBD are right angles, aren't those also congruent? Yeah, all right angles are congruent. So you could say that as well. So we'll use the one they give us just so we know that the symbol is congruent. Angle EBA is congruent to angle CBF. But if you did say right angle, the right angles, that must be fine. Name the perpendicular bisector. Well, BD bisects. One day here, stop doing that. BD bisects angle, the segment ABC. So BD is the perpendicular bisector. Name the vertex of angle 2. The vertex of all these angles is T. Okay. Name the sides of angle 4. Angle 4 is here, so that is TW and TZ. W, ray. Need something that's not glowing. What? TZ as well. Another name for angle 3. Well, that would be, we could say ZTU or UTZ. ZTU. Another name for angle 1, YTX. So YTX. Again, when naming angles, I know this, because there's so much in that diagram, it can be a little jarring. So when naming an angle, first you find the vertex. Angle 1 here, vertex is T. That has to be in the middle. That's nothing else you need. Then you find the two letters on the sides of that angle. So Y and X. So as long as you put T between Y and X, doesn't matter if it's YTX or XTY, you're good. All right, we're going to classify some angles. So what is angle YTW? What is angle YTW? YTW is what? Is right. I'm just going to say. So YTW is right here. So yeah, that right angle, we have a symbol for it. Okay. So YTU, so we start at YT and go to U. So YTU is what? Obtuse. And then we have XTU, XTU, acute. Now, being that we used all three other letters, probably going to be straight. WXT, no, WTX, so yeah, W2X is straight. I'm not even doing it, you just don't mess with it. Two perpendicular lines. Well, what lines make that right angle? That would be, again, you can name it a couple different ways. I'm going to use the Y, Z, and WX. So YZ is perpendicular line, so it's just line symbol. WX. And the angle bisector is a ray, in this case, TU. So ray TU. All right. Next one. All right. Now we've already talked about the angle addition postulates. But if D is in the interior of ABC, then the measure of angle ABD is equal to the measure of angle CBD. So use the diagram to answer questions. If we know that angle ABE is 48 degrees and angle BBC is 78 degrees, what is the measure of ABC? If we add those together, 48 plus 78, that gives you what, 126? Make sure you use the degree symbol on your answers because we are talking about an angle measure. Angle measure must be denoted by degrees. Okay, unless you want to use radians, I promise you don't. You wait for pre-calc for that. All right, DBC. DBC is 74 degrees, and the entire angle here is 119 degrees. Well, the difference, 119 and 74, be 45 degrees. 15 minutes. All right. Since we know the measure of PQR is 141, that means the sum of these two should add up to 145. So combining your angles, 13x and 10x gives you 23x. Positive 4 and negative 1 make a positive 3, and that should equal 141. Subtract 3. 23x is equal to 138. Dividing by 23. X is something. 6? Yeah. So x is 6. Let's plug in for SQR first because 10 times 6 minus 1 is pretty easy. That's 59. All right. And plug the other one. 13 times 6 plus 4. 13 times 6 is 78. Plus 4 is 82. And if we add these two together, we should get 141. Which means you could have found PQS by taking 141 minus 59 as well. Perfectly fine. Again, we know that DEF, the entire angle, the big angle, line angle, 7x plus 4. DEG, so this part of it is 5x plus 1. And GEF, this part is just 23. So the sum of that should be 7x plus 4. So combine your like terms, 5x plus 24 equals 7x plus 4. Subtract 5x. 24 is equal to 2x. Subtract 4. We get 20. Divide by 2. X is 10. So plugging that in, that gives me 5 times 10 plus 1 is 51. All right, if I add 51 to 23, we get 74. Getting the degree. Say you have to put them there, you should always. Easy to forget. So, no my degree symbol sometimes apply. All right. Go ahead and try number 5. Be a couple minutes. Got to be timed right there. Alright. Now before we even get started. So we're given that JKM, so JKM is 43 degrees. MKL is 8x minus 20, and JKL, the entire segment. If I add these together, I should get 10x minus 11. So combining these two, we get 8x plus 17 is equal to 10x minus 11. Subtract the 8x over, add the 11. We get 28 is equal to 2x, which means x is 14. Plug that into for MKL. 8 times 14 minus 26. 8 times 14 is 112 minus 26 is 84. No, 86 in it. Yeah, 86. All right. Plugging it out was a little bit easier. 10x, 10 times 14 minus 11 would be 140 minus 11, which is 1. All right, next page. Last page. Okay, finish. All right, we have a straight angle, which means this adds up to 180. So DEF, right here, we're just going to put 180 degrees, no choice there. DEG is 23x minus 3. DF is 12x plus 8. Combine that to get 35x plus 5 equals 180. Subtract 5, 35x equals 175. And dividing by 35 gives you 5. So 23 times 5 minus 3 is 115 minus 3, so 112. And I can just say what's left out of 180 is 68. Plugged it in, but 12 times 5 plus 8 is 60 plus 8, so yeah. All right. Here we're given TUW is 5x plus 3. WUV is 10x minus 5. And the entire set, two angles add together, add to be 17x minus 16. So that gives me 15x minus 2 equals 17x minus 16. Subtract the 15, add the 16. We get 14 is equal to 2x, which is 7. So, TU. So, TUW is 5 times 7 plus 3, so 38. WUV is 10 times 7 minus 5, so 65. And if I add those two together, it'll be easier to do that. So 9103. Angle ECD is 6 less than 5 times the measure of BCE. BCD is 162 degrees. Now, again, everybody's taken down to 1, so we know in these cases when they give you information about one object and no information about the other, in fact, the information of one object is based on the information of another, then that object they give you no information about is X. It didn't tell us anything about BCE. So BCE is X, which means BCD is 6 less than 5 times. So 5 times X minus 6. The whole thing added together, so 6X minus 6 is 162. Add 6 over 6X equals 168, which gives me 28. So angle ECB, or BCE, is 28 degrees. And if I take 28 off of 682, so far first 134. I can also plug in 5 times 28 is 140. 140 minus 6 is 134. Either way, you do this. Same answer. All right. Let's use the diagram to answer the following questions. Here we have ADF. ADF is 6X plus 26. And EBF is 2X minus 9. ABE, there's some. Okay. So if I add these to get 2 together, it should equal 11X minus 31. So 8X plus 17 is equal to 11X minus 31. Subtract the 8X, add the 31. We get 48 is equal to 3X, which means X equals 16. Now they want to find ABF. So 6 times 16 plus 26 is 96 plus 26, which is 122. Last one. We know that angle BD bisects PBE, and BC is perpendicular to BA. Right over here, bisects congruent. Yes, the CBE is 3x plus 5. 5, 6. PBE is 7x minus 19. So we know those segments are equal to each other. X plus 25 is equal to 7x minus 19. Subtract 3x. 25 is equal to 4x minus 19. Add 19 over. 44 equals x. X is 11. Now what they want to know is measure C, ABD. This is 90. Angle CBD is 3 times 11 plus 25, which is 3 plus 25, 58. So the measure of angle ADB is 90 plus 58 is 148. Now, that is it for us. You did make it in time. All right. So homework is just 1.5. Okay. Yes, all that covers 1.5, so I have pretty quick. So, yeah. You guys have a good weekend. You have 3 days, so it's nice. No school Monday.